Welcome to this tutorial on Simulink best practices for large and complex models. In this session, we'll explore modular design, the foundation of building effective and scalable large-scale models in Simulink. Simulink offers several subsystem types to support modular design. A basic subsystem groups blocks for clarity but runs in line. An atomic subsystem runs as a single unit, useful for execution control and code generation. Library subsystems allow reuse across models by linking to a shared library. A subsystem reference stores the contents in a separate file, great for modularity without a full model reference. Model reference brings in an entire model as a component, ideal for team collaboration and large projects. And variant subsystems let you switch between different implementations for things like design alternatives or operating modes. Choosing the right type keeps your models organized, scalable, and easier to maintain. Let's take a closer look at three important modularization options in Simulink. Library enables reuse across models and ensure consistency. Updates apply everywhere they're used. I would recommend using library for small-scale models, such as matrix operations, filters, etc. Subsystem reference stores a subsystem in a separate file, improving modularity and version control. Model reference brings in an entire model as a component, ideal for large systems, team collaboration, and faster loading and builds. This table summarizes the features of library, subsystem reference, and model reference in Simulink. Feel free to take a moment to look it over. Organizing Simulink models into a hierarchical structure with clear boundaries between components is a best practice for managing complexity in large-scale system design. This involves breaking down the system into logical units using subsystems, subsystem references, model references, and library, each serving different purposes based on reuse, encapsulation, and simulation performance. Clear boundaries improve modularity, making components easier to understand, test, and reuse across projects. They also help enforce encapsulation, so changes in one component have minimal impact on others. To visualize the modeling structure, Simulink's Dependency Analyzer provides diagrams of model dependencies and hierarchies, which helps identify how components are interconnected. All right, I hope this gave you a better understanding of the principles of modular design in Simulink. In the next session, we'll discuss Simulink model interfaces. I look forward to your participation.